Hello everyone, welcome back to my channel. So today I've come with a new video in physics and the name of the topic is motion in one dimension. And this is one of the important chapter and confusing chapter in physics. So we will be proceeding slowly with each and every topic and I will be making many videos on this chapter. Okay, I will not be explaining everything in one, but we'll explain each and every topic in separate videos. Okay, I will disintegrate the topics. So today what we are going to do is we are going to proceed with the basic part of the chapter. Basically, the chapter have three parts. First are the basics, second is the graph, third is the formula that we need to apply for calculations of few sums that will be given to us. So each and every topic has, or rather each and every part of the chapter has many topics to be covered. Today I am going to proceed with the basic, that is the part A. Okay. So without taking much time, let us proceed with the chapter. So already written on the board the name of the topic, that is motion in one dimension. So at first, let us forget about the chapter. What the chapter deals with, what is the thing, let us forget it. What we will see is, we will see the name of the chapter, that is motion in one dimension. Okay. So at first, let us see what is motion. Motion is the change in the position of the body with respect to other fixed objects around it in unit time. So, suppose let us take into consideration an example. Okay, suppose point A. I will explain you this definition with the example. Okay, I'll not explain this separately. I've already made one video on motion. I'll give the link in the description. You may check it from there. But for the time being, I'm just making a recap of the things that I've already told in that video. So, suppose a point A is a human. Okay, point A is a human, and it can move. Okay, point A can move because it is a human. We know humans can move. Humans can move. Now, the two tree, that is tree 1, tree 2 and the house, these are the three objects that are on the road. So by applying our common sense, or it is a common observation that these objects are the fixed objects. We cannot expect a house to walk, or we cannot expect a tree to run, because they are all the fixed objects on the earth. Once constructed, house is a fixed object. Once the tree has grown up, it is a fixed object. Okay, fixed object in the sense it can move. Okay, biologically if we are telling, trees can move because growth will be there, right? So they will grow, but they will not, means they will not show any kind of locomotion. Okay, now it's a term of biology that I have used here. Locomotion means, suppose if a body is changing its position, like if I'm just staying here sitting at a place and I'm moving my head, I'm moving my hand, that is the movement. But suppose I've got up from here and I've went and sat to another place, that is the locomotion, because my position is changed. But if I'm just moving my hand, I'm moving my head, I'm speaking, there's a movement in my body, so that is your movement. Okay, so these are all the fixed objects on the road, the two tree, the house. But the point A, which is referred to as a human over here, has the ability to move, that is, it will show locomotion. So, as the definition suggests, that change in the position of the body with respect to other fixed objects around it. That means what? These are the fixed objects, and suppose the point A is walking this in this direction. So, according to point A, or according to A, what will it feel? It will feel that it is in motion. Why? Because with respect to the other fixed objects around it, that is the two trees and the house, it will find that its position is changing with respect to unit time. That is, with respect to time. If unit time, we can take seconds. So, in every second, the position of the body is changing with respect to the other fixed objects around it. Okay, so that is the definition of motion. Now, motion in one dimension, what does it mean? Let's understand what do we mean by saying motion in one dimension. Very, very important. Now, first of all, I will not be going in detail with dimension, the word dimension, because it has, a big explanation. That the word dimension has a big meaning rather. So, just in a particular line, I am telling you that dimension is required to establish the position of a body. Okay. Now, the order of the topics that I am going to follow will be according to my reference material. Okay. So few topics I will explain today and few in my upcoming means next videos. Okay. So if we are just taking into consideration the word dimension, then what is it exactly telling? Now we will not say what is it exactly telling, because if we are means trying to know its exact meaning, then I need to explain you many things. Okay, and I will go away from the chapter. So I don't want to proceed with that. But know one thing, that is, it is required for the establishment of the position of a body, not the, I will not say the, a body. Okay, now let's take three situations. First situation, I'm just changing the ink of my marker. First position, sorry, not position, situation. Second situation, third situation. In first situation, what we are seeing is, suppose the body A is moving in this direction, that is A, right, left. Suppose to number 2, right, left, up, down. Okay, and number 3, right, left, up, down, and sidewise. Okay, so these are the three situations. In first instance or situation, we are seeing that the object is only moving front and back. In the second situation, we are seeing that the body is moving front and back, as well as it is moving up and down. In the third instance, we are seeing that the body is moving up and down, right and left, that is front and back, as well as it can also move sidewise, that is three dimension. This is also written as 1D, that is one dimension, 2D, two dimension, 3D, three dimension. Now it's my request, do not mess up or do not try to relate that, Inox, Inox is 3D, or any cinema hall, I'm taking the example of Inox, with this 3D. Inox is 3D with this 3D. These two 3D are poles apart different. So do not mess up with these two things, because we are learning physics. Okay, so many terms you will find which are related to such kind of a thing, but we have to be aware of the fact that we should not confuse ourselves with those misconceptions. So do not mix up the cinema halls 3D with this 3D. So let me not explain 2D and 3D, because our topic is 1D, one dimensional. So let's drop these two. What are we left with? We are left with 1D. Now 1D means what I have told. It can only move front and it can move back. Right? That is your 1D motion. So that was the explanation of the name of the chapter. What does the name of the chapter suggest? That we have come to know. Now let's proceed with our topic. So first you have scalar and vector quantity. Scalar and vector quantity. Now, suppose let us talk about scalar at first. Now, if we want to represent any kind of a value, okay, then for scalar, what do we need? We need the magnitude, we need the unit, right? So, in order to establish a scalar quantity, I will not say establish, in order to represent a scalar quantity, we need these two parameters. That is magnitude, another is your unit. Suppose I am telling length, suppose 2 meter. These are the two, the not characteristics, these are the two things that we need to establish, that we need for the establishment of scalar quantity. So we have got our magnitude, we have got our unit. So both the things are there. So we can say that this is a scalar quantity. Right. Now, in many books, in many schools, they tell that scalar quantity is a kind of quantity that can be expressed only by its magnitude. Now, when you will ask them that why are we not considering unit over here, they will say that unit is necessary. Even if we are only telling magnitude, that means the word unit is hidden over here, because without unit, only the magnitude is useless. So we will not say unit separately. Along with the magnet, we can say unit, or we can omit that portion, because unit is important. Unit is important, and by not telling it also, we have to give it. But while I tell you about the chapter, I always include this topic, not topic, this name or this word, that is unit. I never omit it. Because there are many people who have the tendency to make mistake, that is, if we only say 2, then they think this to be a scalar quantity. No. If we are telling length, then only telling 2 is useless. It is nonsensical. It does not have any sense. We have to write the unit. In physics, anything without unit will give you a 0 in exam. Not only in exam, if you are all proceeding with high studies in physics, without unit, it will not make any sense. Wherever unit is possible, we have to give it. Indeed. Okay? So that was our scalar quantity. Coming to vector quantity. Now for vector quantity, first two things are already told. That is, the things that we are including for scalar, we have to include here also. Magnitude, unit. But the third parameter, which is the most important and which distinguishes vector from scalar, is direction. This is the most important term for representing a vector quantity. Like, for example, let's take the example of displacement. Okay, now in one of my shorts, I've already explained what is displacement. I'll again explain you today, but for the timing, I'm just telling you that displacement is greatly dependent on direction. Without telling the direction, displacement cannot exist. So if we are to represent displacement, then we have to say 2 meter towards, now we have to tell a direction, suppose east. This east is the direction. Now only telling 2 meter means what? It is a scalar quantity. But something needs to be there which will differentiate a vector from a scalar, that is the direction. For scalar, writing only 2 meter will work. But for displacement, the word east, that is not east, any direction, plays a great role. Okay, now let's proceed with distance and displacement. Okay, so one thing I want to tell you, that is, it is written in my reference material. I've missed out that part. If you want to represent any kind of vector quantity, then in order to make sure that it is a vector quantity, you have to give one arrow on top. Either you can bold the text like this, or you can give an arrow. Okay, now if you are giving exam, at that point of time you will not have the option of bolding your text. You cannot darken it up. But what you can do at the most, with a pencil or with a pen, you can draw the arrow. So that's a representation of a vector quantity. Okay, now let's proceed with distance and displacement. You know, this vector is a separate chapter in class 12. Okay, this chapter vector. Okay, this is a huge topic, this vector. So this small information is nothing in front of the chapter which I told you. It has many more that we have to deal with. So for the time being, let's proceed with class 9 only. So distance and displacement. At first, let me proceed with distance. Suppose I give you a two situations. First situation, suppose a body A starts walking from the initial position and ends here. That is the final position. And in second instance, what we are seeing is, suppose a body starts from this point, that is your initial position, takes a round and comes back to its final position. Okay, and the initial and the final position are the same. Okay, so if a body is coming back to its original position, then original position in the sense the position from where the body is starting, it is coming back to the same position after completing one round, or after completing one laps. Okay, so at first let us see the first situation. Suppose the length of the road is 10 meter and the perimeter of the circle is, suppose, 20 meters. Okay, suppose. So the distance traveled by the body A in the first case will be 10 meter. That is distance equals to 10 meter. Now suppose the body goes first comes from this point to this point and again returns to its initial point. Then it covers 10 meter twice. So what we will do, 10 meter plus 10 meter, because it is covering twice. First coming from the, suppose if, now forget about initial and final. Suppose this is point I and this is point F. So point I, from point I it is starting and going to F. Again from F it is coming back to I. So it is covering the part two times. So that is making your distance 20 meter. So the distance traveled by the body is 20 meter. That is 10 plus 10. Coming to the circular path. Now if the body is making one laps, or the body is walking on the circular path once and making one complete circle, then the distance traveled will be 20 meter, right? Now in case if the laps it's two times 2t, okay, then what will the distance become? Twice. So 20 meter plus 20 meter, that is your 40 meter, right? So that is your distance, that is the total path covered. Doesn't matter in which way the body is going, in which point it is returning, what way it is walking, any way, any time, any direction, or in any case, the total path covered by the object will be its distance. Okay, now coming to displacement. First situation. So, acha, let me draw the second situation also. Suppose for displacement, again the body starts from the initial position denoted by point I and comes and stops at F, that is the final position. Now here the body is moving eastwards. The body is moving eastwards in a particular direction. So, first of all, just note the point. I've told you the direction. I've told you the direction. That means from here, I think one basic idea you have got. That is, displacement is a vector quantity, whereas distance was a scalar quantity. Because at that point of time, what I have told, in any direction it can move, it will not affect the value. So, distance is a scalar quantity, but displacement is a vector quantity. Why? Because I give you the direction, right? So, it is moving in a particular direction. Now, suppose if, let's take the same measurement, if the length of the road or the track is 10 meter, then what we will say, 10 meter due east is the displacement of the body. Now, suppose from point F it comes back to point I, then in this case we will not do 10 plus 10. What we will do? 10 minus 10. Why? Because it has retraced the path. Or in a simple version, if the initial and the final point of a body is same, then the body is said to be, or rather the body's displacement is said to be 0. Now think displacement in this situation. Now at first let me explain you one small topic, then coming to it. Displacement is the amount of place displaced. Okay, suppose this is point A and I have drawn it here. Okay, and you have closed your eyes. Okay, and you have closed your eyes, and the moment you open your eyes, you see that the body have come here. I repeat, suppose a body was standing here and you have closed your eyes, and the moment you have opened your eyes, you have saw that the body have come here. So the body has traveled certain amount of path. That path, the length of the path or the amount of the path covered is your distance, total path covered. So no issue with this. But this is the place displaced. Okay, this is the amount of place that has been displaced by the body A. First you saw, while before you have closed your eyes, you saw that the body is here. And the moment you have opened your eyes, you saw that the body have come here. So it is nothing but what? It is the place that has been displaced, right? Place that has been displaced. Clear? So that is your displacement. Now suppose before closing your eyes, you saw the body is here. And after you opened your eyes, you saw the body is still here. Okay. Now, what will be the displaced place for you? According to you, you will think that the body have not traveled only, because the initial and the final positions are same. Wherever it was standing, it is standing in the same place. Before and after closing the eyes, the position of the body is same. It does not have any effect. So for you, the initial and the final position will be same. So can we say, by looking at this particular situation, that the body is displaced? That the body is displaced? Can we say that? No. Here we can say, because we have saw that there is a change in the position, but here there is no change in the position. How can we conclude that yes, there is a change in the position? The body is displaced. So here the displacement will be 0. But here if the length of this track is 10 meter, okay, suppose 12 meter, then distance will be your 12 meter, but displacement will also be 12 meter. Okay. Now suppose one more situation I'm giving you. Suppose now you see that the body is traveling in this path and it stopped here. Okay, the body have traveled in this way and it has stopped here. This is it. This is the initial position. This is the final position. So as per this concept, our distance will be this total path covered, right? As I've told you, this is the total path covered. So suppose this full length of this road, suppose 100 meter. So this becomes your distance. But can we say that this 100 meter is your displacement? Under any circumstance, can we say that? It's a big no. We cannot say. Why? Because displacement is the amount of place displaced. Now suppose you have closed your eyes. Okay. Suppose you have closed your eyes. And while you have closed your eyes, you saw that the body A was here. And after you have opened your eyes, you saw that the body is here. Now, will you be able to confirm that whether the body have actually traveled or not? I can just move the body in this way also. It was here, I have brought it here. It can be in this way also. It can be in this way also. You are not sure that yes, the body have distance traveled in this path only. I've told you that that's why you are confirmed. But really, if I have told you to close your eyes, and if you will see that after, before closing the eyes, you will, if you have saw that the body is here, and after opening the eyes, if you see that the body is here, then obviously you will think that the body have traveled in this way, and it is the amount of place displaced. So you will find out this particular length. This particular length you will be finding. But you're, because you're not confirm of the fact that really the body have traveled in this random motion. But if I have told you to open your eyes, then you will, means, what will be the thing in front of you? What you will see? You will be seeing that the body is traveling in this manner, right? So in that case, this becomes your distance. Okay, this becomes your distance and this becomes your displacement. Now suppose I told you to close your eyes. The body traveled in this way and came back to its this position only. The body traveled and came back to its same position only. So in that case, displacement will be zero. And in other words, displacement is also called the shortest possible path. So the body has traveled so much of distance. But what was the shortest possible path? This was the shortest possible path, right? So that is the basic difference between distance and displacement. It's a very confusing matter. People have the tendency to confuse themselves with these two topics. So better to make the concept clear by now. Okay. So now coming to it. Point. Now A starts from the initial position, ends up in final position. Now you will see that the body is displacing 10 meters. So distance is 10 meter obviously because it's the path covered, not talking about it. But displacement is also 10 meters. And one more thing you just see, for a straight path in a particular direction, I repeat, for a straight path in a particular direction, distance and displacement is same, right? Now, if it is coming back to the same position from where it had started, what will be our observation then? We will see that the displacement is zero. Same for your circular path. I'm not drawing it. So if a body is starting from a particular position, taking a round and coming to its that position only, then the displacement is zero. But distance is the total path covered. That is the perimeter of the circle. Okay. So, and the unit, both the unit of distance and displacement is your meter. The SI unit is meter. So that was all for today's video. I will not be proceeding in further. Okay, in my next video I'll proceed with our next topic. So for today till here, thank you everyone, and stay tuned for the next videos which I will be uploading for this particular topic. So till then, bye.